All right, good morning, mathematicians, or good afternoon, depending on when you are watching this. All right, so today we are going to cover lessons 2.2, and in the next video, you're actually going to cover 2.3. These are both pretty lengthy lessons, so please bear with me as we work through these together. Okay, so with that, let's go ahead and dive right in. Our focus question for this investigation is how can you use rate tables to find missing values? How are rate tables similar to scaling quantities and solving proportions? Well, we're gonna take a look at this first scenario. All right, so let's go ahead and give this a read. Julia is in charge of ordering pizzas for a camp dinner. She wonders whether to order the pizzas from Royal Pizza or Howdy's Pizza. So here they give us some prices. Okay, we're going to take a look at these in a second, but I would like to get down to the question here at the bottom of the page. You can use these ads to determine the cost of any number of pizzas by creating a rate table. How much would it cost for one pizza from each restaurant? So before we get into the rate table or creating a rate table, let's first see if we can find the cost for one pizza. Yes, thank you. Let's find the cost for one pizza from each restaurant. Okay. So let's do Howdy's in red. Okay, and then we will do Royal in blue. Alright, so I encourage you to pause the video right now. See if you guys can find the cost for one pizza. See if you can set up a proportion. Alright, so hopefully you took the time to pause the video. Let's go ahead and get to solving this. So, if you don't write it this way, that's okay. Just remember to be consistent when you write your proportions, okay? So 15 pizzas is $195. And what do we want to know? Well, we want to know the price for one pizza. So we're going to write one pizza over here. And we're going to write X dollars because we don't know how much one pizza costs. Okay, so now let's see. What can we do? I say let's test what do I need to multiply 15 by to get 195? Well, let's do that really quick. What is 195 divided by 15? And that is going to give me 13. I'm going to write that over here, 195 divided by 13, because that is, divided by 15, because that is exactly what I typed into my calculator over here, which is why I want you guys to write it down too. So 195 divided by 15 is 13. So I'm going to multiply this side by 13. Therefore, I need to multiply this times 13, and that gives me X is equal to $13. So $13 for one pizza from Howdy's, of course. Okay, so there's our first price. Now let's do the same thing for Royal. They say 10 large pizzas, so 10 pizzas for $120. Oh, and there's my cat. Okay. And it's going to be a similar proportion here. We want to know the price for one pizza. Boom, there we go. Okay, let's figure out how do I go from 10 to 120? Well, I just multiply by 12. So if I do it to the left side, I must also do it to the right side. So 1 times 12 is just 12. So X equals $12. $12 for one pizza from Royal. And there we go. Okay, So now that we know the cost for one pizza from each of these restaurants, we're gonna scroll down here. I'm gonna scroll. You guys are gonna turn to the next page, and we're gonna complete the table with the prices for each quantity of pizzas shown. All right. So I guess we're starting with Royals here. Let's go ahead and take the next minute or so to write in. Actually, not the next minute. Let's take 5 minutes to figure out the prices for these two restaurants. So we found that one pizza from Royal is 12 and one pizza from Howdy's is 13. All right, I encourage you to pause the video and complete this table with the number of... Oh, I already fed him. My cat just got fed twice. Okay, sorry, back to what I was saying. You're gonna pause the video and you're going to fill in the rest of this table according to how many pizzas we're gonna order from each restaurant. Okay, so hopefully you pause the video and have filled in this table. I'm gonna fill it in really quick, so hopefully you have numbers that are very similar to these. Right, so let's see. It's gonna be 240. It's going to be 1200, that's going to be 2400, and then I believe this is going to be 1800, and then 180. Let me just double check that in my calculator really quick. 12 times 15. Cool. All right, and I'm going to fill in Howdy's. This is 13, 26, 39, 52, and 65. This is 130. This is 260. This is 1300. This is 2600. And this is going to be 1950. Okay, and there we go. All right, so now that we have this table filled in, hopefully you guys are starting to recognize some patterns. How are we actually finding these numbers here? We're gonna say how we do it in just a second, but I would like you to spend the next about 5 minutes. Let's go ahead and answer these questions 2, 3, and 4. Okay. So let's spend the next 5 minutes answering these questions, and we'll come back together to class and compare answers. All right. So hopefully you pause the video and have worked on these. So how much will 53 pizzas from Royal Pizza cost? Well, if the one pizza costs $12, okay, and we need 53, so we're just going to multiply these two things. 12 times 53, and that's going to give me $636. Okay, how much will 27 pizzas from Howdy's Pizzas cost? So our price per pizza is $13, and we're just going to multiply that by the number of pizzas. So 13 times 27 is equal to 351. So we have $351 here. Okay. This next question is it's kind of like working backwards here. So it says that campers consider their budget. How many pizzas can they buy from Royal Pizza with $400? So they don't want to spend any more than $400. $400 is the total amount they can spend. So let's see, where are we buying from? We're buying from Royal Pizza. So we should have taken 400 and divided it by the cost of one pizza. So let's go ahead and do that. 400 divided by the cost gives me however many pizzas I can buy. So this gives me the number 33.3 repeating. But let's go ahead and make this realistic and say, well, with $400, I can really only buy 33 whole pizzas. Okay, the next question said, what if they only have $96? Similar process, we want to spend only $96, so we're going to see how many pizzas we can buy by dividing it by 12, and this gives me 8. So 8 total pizzas. Excuse me. Okay. We are on question B1. All right, here's where we're going to start breaking down the process. So, if you know the price of one pizza, how can you find the price of additional numbers of pizza? So I would like you to explain in words. How did we come up with all of these numbers? For example, in questions 2 and 3, how much will 53 pizzas from Royal Pizza cost? How much will 27 pizzas? Please explain in words, how did you find the price? All right, hopefully you said something along the lines of, we are multiplying, we're going to multiply the price of one pizza, by the number of pizzas. I don't have any space, so I have to go all the way over here. So multiply the price of one pizza by the number of pizzas. So question 2, we're now going to write an equation. And equations are super nice because equations help us. What am I trying to say? Equations make it easy for us to apply. I don't know. Okay, I'm sorry. I'm losing my train of thought. Equations are nice because we can plug in any number that we want, and it'll give us what we're looking for. So for example, number 2 says, for each pizza place, use your strategy from part 1 to write an equation for the total price P for any number of pizzas N. Okay, so the first thing we should emphasize is that P stands for the total price. Okay, and N is the number of pizzas. Okay. Now, when we write the equation, we are going to follow this description exactly how we wrote it. We are going to multiply the price of one pizza by the number of pizzas. So for Royal Pizza, what was the price of one pizza? Well, we said it was $12. So we're going to take 12, and we're going to multiply that by the number of pizzas N. So this equation, P equals 12N, will tell me the cost of however many pizzas I want to buy at Royal Pizza. And before we move on to Royal, I would like to label the parts of this equation. So N represents the number of pizzas. 12 represents the price of one pizza. And of course P right here is our total price. Okay, now with knowing that, let's go ahead and try and write an equation for Howdy's Pizza. So what was the price of one pizza? We said that was going to be 13. And we're still multiplying by the number of pizzas. So our equation is P equals 13 times N. Now, how does our equation help us solve problems such as those in questions A, part 4? So part 4, if we look back here, right, we were talking about budget, right? What did we do? We took their budget here, right? Their budget was $400, and what did we divide by? What is 12? 12 is the price of one pizza. So we took our budget, we divided by the price of the pizza to figure out how many pizzas we could buy. So we could say here, we divided the price, the total price, by the price of one pizza to get the number of pizzas. To get the number of pizzas ordered, I'll say. To get the number of pizzas ordered. Okay. All right, let's keep going. We are in the home stretch. Okay. So, we're gonna, Howdy's has some hidden fees going on here. So it says Howdy's listed price is valid only if you pick up the pizza. So if you request delivery, they charge a flat $5 fee for any number of pizzas. So let's go ahead and copy the pickup prices first because we already have that information. We don't need to redo all of this. So one pizza costs $13, 26, and so on and so forth. 52, 65, and that's 130. Remember, you should be paying attention to the number of pizzas bought here. Okay? All right. Now, what does it mean, a flat fee of $5 for any number of pizzas? So, really, we're just going to be adding 5 to each of these values down here. Each of these pickup prices, we're just going to add $5 to them. So, let's say this is 18. Let's say this is 31. This one is 44, 56. Oops, what am I doing? 56, 57 is what I meant to say. 57, and then this is 70, and then this, of course, is 135. Last one is 200. Okay. So what I'd like you to do now, after we've looked at this table a little bit, what patterns do you see? Let's go ahead and pause the video. I would like you to talk with your partners or your group members. Talk about the table. What do you notice? What's happening while the numbers are changing? And we will share as a class. Okay. All right. So patterns. What patterns do we see? I think an obvious one is that the purple numbers here that I've written are always 5 more than the red, right? So we can say that the delivery price, the delivery price is always 5 more than the pickup price. Another pattern that you may have noticed, well, how much did we increase 13 by to get to 26? Yes, we added 13. How about 26 to 39? We also added 13. What about 39 to 52? Plus 13, 52 to 65? Yep, it's the same. So it looks like we're adding 13 to the price each time we increase the number of pizzas. That makes sense. So let's write that down as well. So we'll say for each additional pizza, the price increases by 13. Okay. What about in the delivery prices? Is it the same thing? Can you guys take a look at that really quick? Is 18 to 31 plus 13 is 31 to 44 plus 13, and so on and so forth? Why, yes, it is. It's the same. These are all plus 13. Okay, and this will come into play with the next question here. It says in question B, part 2, you wrote an equation for the cost of pizza at Howdy's Pizza. Let's go ahead and write the equation on the left side in the column here. We wrote the equation P is equal to 13 times N. Okay, and the question is asking us, how does the information represented by the equation show up in the table? Let's go ahead and label what each part of the equation means again. So N is the number of pizzas. 13 is the price of one pizza. Sorry, it's getting a little harder to write here. And then P is the total price. Okay. So taking a look at my table, where is the total price represented? Well, total price is represented, how do we describe that? In these areas here that I'm highlighting in yellow. Right, so the total price is, we could say, within the table in the price rows. So total price is in the bottom two rows. Okay, where can I find the number of pizzas? Well, the number of pizzas is in the top row. Is in the top row of the table. Lastly, where does 13 come into play? Well, we said 13 shows up there. So 13 is found, or 13 is how much we're adding for each additional pizza. For each pizza is what I'll say. For each pizza. Okay. Woo! We are almost there, you guys. Almost done. Okay, we have to graph this now. So what I need you guys to do is we're going to graph two lines. So some kids in period 5 they accidentally graphed they made bar graphs, which is nice, but that's not quite what we're going for here. So let's see. I'll do delivery in purple. So please make sure you have two different colored pens, or you make these lines different somehow, okay? And then I think I did pick up in red. Yes. So let's go ahead and do that. Okay. So let's review quickly, how are we going to graph these? So we want to graph the number of pizzas up to 10. So looking at Howdy's costs, that's going to be, I'm going to draw a star next to it. We are looking at pickup prices. Okay, so our first coordinate is going to be, for one pizza, it costs $13. So we're going to plot that onto our graph here. So find 1 on the x-axis, which is the number of pizzas, and then we're going to go all the way up to 13, which is slightly below halfway there. Okay, and there we are. We're going to do this all the way up to 10. So go ahead and pause the video. Go ahead and graph your coordinates, please. All right, hopefully you paused the video and you have graphed your coordinates. I am still graphing mine. So 226, 339, which is just below 40, 4, 52, 5, 5, 5 we said is 65. $5.65 and 6.78 is about right there. And then, oops, that is too close. There we go. 7.91. $8.104. It's about right there. And then 10.130, which is right there. Okay. Whew, sorry. Let's go ahead and connect our dots, please. And there we go. And let's go ahead and plot delivery as well. So 118. I'm going to speed up my process a little bit. I'm going to graph 570. 570 is about right there. And then 10 would be about right there. Okay, and I'm going to connect my dots. And there we go. We got two separate lines. Okay, how are the graphs similar and how are they different? Some of you might say they're almost the same line. So let's go ahead and write that down. They are almost the same. But what's different? Well, we could say that the delivery line is higher than the pickup line. Okay, so those are the major differences right now. Well, they're almost the same, but then one is just higher than the other. Okay. Now, this is our last question, guys. In 2.2, for each graph, which coordinate pair represents how much one pizza costs? So we are going to have two different columns here. So there's pickup, and then we have delivery. Okay. So I'm looking for a coordinate pair. So remember that coordinate pairs are always written like this: x, comma, y. So I need an x coordinate and a y coordinate tucked away in parentheses. So how much one pizza costs? Well, if we find 1 on the x-axis, what is our y-coordinate? We said that was 13. What happened? What about 0 pizzas? What do you think? Well, 0 pizzas should cost $0, right? Okay. Let's go ahead and do this for the delivery option now. How much does 1 pizza cost? Well, 1 pizza costs $18, right? That's 13 plus the $5 delivery fee. So there's our coordinate, 1, 18. What about for 0? If you said 0, I want to ask, well, remember on the ad, going back up to here, this ad right here, it says that they charge a flat fee for any number of pizzas. That is a horrible line. They charge a flat fee for any number of pizzas. Right there. So, does that include 0 pizzas? Technically, yes, that does. So, if we have 0 pizzas, how much are we paying for delivery? Well, we're just paying that $5. So in real life, realistically, this doesn't make too much sense. You're not ordering anything, so why would you pay for delivery? Um, I mean, unless you just want the delivery person to say hi to, but otherwise, um, yeah, it doesn't make any sense. But that's okay. All right.